from Unit 3 here. So we are going to do what we call graphing the related quadratic. So I have a quadratic equation set equal to 0. That's what you want. When I say, and you don't need to write this, but when I say graph the related quadratic, basically what we're going to do is graph y equals x squared minus 4x minus 5 for this very first one here. And then I will see if you guys can figure out how we would go about finding the solution to that actual equation. So the very first question here, this is in standard form, so ax squared plus bx plus c. Does anybody remember how to, you can't just look at that and see the vertex. Does anybody remember how to find the vertex from standard form? There's like a teeny tiny little formula. Ethan, you remember? Yes. Okay. So we're just going to do, you can't see the vertex in standard form. It's not like I don't look at that and go, oh, it's -4, -5, which some people do, so don't do that. Negative b over 2a, and then you plug in whatever that value is for x and get the corresponding y value. So negative b is the same thing as saying the opposite of b. So for this question, the opposite of b would actually be positive 4. And then our a value is just 1 because we just have an x squared. So it'd be 4 divided by 2, which is 2. So that's the x coordinate of my vertex. Now, y coordinate of my vertex, if you want to write it out or you want to just grab your calculator and plug it in, totally up to you. Everywhere I see an x, though, in this equation, I'm just going to replace it with a 2 to find the corresponding y value. So I'm just literally just plugging this into my calculator here real quick. So if we plug in 2, our y value is -9. Other thing we need to graph, maybe unless you guys want to make a table, which I think is a lot of extra work. So does anybody remember what I mean by putting the word pattern underneath there? Yes, a times 135. Now your a value is just 1, so this would be 135. All you got to do, we're going to find the point to -9. That should be the very middle, the vertex of my parabola. And then you don't have to write this if you remember this, but you're going to go over 1, up 1, then you're going to go, how to use the pattern, over 1, up 3, and then over 1, up 5. We could continue that pattern if we needed to, if we had a bigger graph, but on this one it should fit just totally fine. So just on either side of that vertex, over 1, up 1, over 1, up 3, it's just a relationship with the perfect squares. That's where that pattern comes from. Over 1, up 5. The next step in the pattern would be to go over 1, up 7, but that is not going to fit on the window that we have in front of us. Now, if I'm asking you to solve that equation, that x squared minus 4x minus 5 equals 0, how could the graph get me to the solutions to that equation? What would you be looking for? The x-intercepts. That's literally it. So if you come to the graph here, that x value makes the y value equal to 0. So that would solve that equation. That's what we're trying to do. So when I rewrote the related quadratic where I have the zeros where we have y, so I want my y value to be 0, that's just looking for your x-intercepts. Now there's 2 of them here, 2 places that parabola crosses. Don't write these as points, because if I'm solving this equation, you're just telling me the values of x that you would plug in. So you would just have -1 and +5. And you don't have to write them in a particular order or anything like that, but don't put parentheses around it and don't write it as like -1, 0. It's not asking you to identify those points. It's asking you for the x values that would solve that equation. So you'd have 2 answers here, -1, +5. Anybody have a question? Okay, let me try one more with you. Now, this one also, standard form, can't see the vertex, got to do -b over 2a. So negative b, since it's already -6, would be +6 over 2 times my a value here is -1. So it'd be 6 over -2. So the x coordinate of my vertex is actually going to be a -3. Now, very important, if you are plugging this into the calculator, when you square -3, it will make it positive, but on this equation, see how you have a little negative in front of the x squared? So either with your calculator or if you're doing this by hand, don't forget you're going to end up multiplying that first term by -1. On the calculator, I just put the little negative sign out in front of the parentheses where I'm plugging in the -3. And make sure when you're plugging in a negative number, this is -3, use the negative key. I know this is a lot in this question, but it's really good to practice this. So negative for a negative number there, we're plugging in. But between the terms, I have -6x. So you guys can see I use the subtraction key here. And it's a little bit longer and a little bit lower than the negative key, so you could be able to tell on your calculator. If you don't do it that way, it might give you an error message. And so in this case, my y-coordinate is 0. Now, to be honest with you, the vertex is on the lovely x-axis, and that's actually going to be the only solution. So just to make sure I satisfy that I'm solving this by graphing, I want to graph a little bit of this parabola just so we could see it here. The a value is -1, so we're just going to go over 1, and then it's up or down the pattern. In this problem, we're going to go down 1. So you're going to go over 1, and then down 3, and I'm not going to go over 1, down 5, because I can see that that vertex is the only place that parabola is going to touch the x-axis, which is what we're looking for our lovely solution. But I am going to graph just a little bit to show that I am graphing the related quadratic to answer the question. But the only solution here would just be the vertex x-coordinate, which is -3. And you can check these real easily. If you want to plug that value into the equation, it should give you 0 as the result. Now, the two at the bottom of the page are in vertex form. So, if I have vertex form, do you guys remember how to find the vertex from vertex form? I'm going to graph the related quadratic, so kind of again, just thinking about substituting in y where they have the 0 in the equation there. Do I need to sit there and like FOIL that out and put it in standard form? No, please don't do that. Please don't make more work for yourself. In vertex form, you can see the vertex. Can anybody raise your hand and tell me what the vertex would be for this one? Opposite copy, yes. Whatever is in here, opposite of what it looks like. It's what it sets it equal to 0. That's where it switches from one side of the parabola to the other. So it's what sets that equal to 0. This guy right here, you're going to copy this number. So it should just be +5, -8. Now, the pattern here would be a little bit different because we have this 2 out in front as my a value in vertex form. The whatever's in front of the parentheses, that's your a value. So don't forget that. You just take that a value, multiply by 135. That being a 2 is going to stretch the parabola, make it more narrow than the ones we were just graphing. So this would be 2, 6, 10. So it's always, whenever you graph these, you go over 1 from the vertex and then up or down the pattern. In this case, I'd go up 2, I'd go over 1, then up 6. This is not going to fit on the graph, but if it did, we would go then, it's over 1 every time, and then I would go up 10, just to remember how to do that from the vertex. So I've got 5, -8, so just over 1 on either side, but this time we're getting stretched out by that a value being 2, so I'm going to go up 2. Then I'm going to go over 1, up 6, and actually that should put you right on the x-axis, which are your solutions that you are looking for. So there's my parabola, the best I can draw. And you're just trying to grab those x values. And again, don't write the points down because you're trying to solve the equation. So you're trying to tell me the x values that would make that equation true. This guy's going to be 3 and 7. Don't have to write them in a particular order. And I have one more to practice with this. What's the vertex if I have negative? I'm going to graph the related, so I'm going to pretend like y equals this to graph it. What would my vertex be if I've got -1/2 and then x plus 4 squared plus 2? What would your vertex be? The very middle of the parabola. Hunter, what do you think? -4, +2. Opposite inside the parentheses at what sets it equal to 0, and then copy what's outside. That's your y-coordinate. Now the pattern here, and I know this has been a minute since we've done this. Remember, if the a value here is -1/2, just do this favor for me, and I'm going to treat that as -0.5. The reason I was having you guys do that is because sometimes if people see a fraction, they're tempted to kind of revert to doing slope and thinking like rise over run. I don't want you to do that. So 135, I'm going to multiply by 1/2, or -1/2. It's going to give you -1/2, -1/2, and then -2/2. And the reason I was having you guys write that as a decimal is just like I said, so you don't confuse it with trying to do a slope. You're going to go over 1 and you're going to go down, just kind of estimate a half. And then I'm going to go over 1, down 1.5, but that will put me on a nice point. And then if you want to continue over 1, down 2.5 to get the next point. So from your vertex, -4, +2, I'm going to be on the halfway mark. But then when I go down 1.5, over 1, down 1 on the halfway mark, and a half would put you right on the x-axis. And that's what we're looking for. If you want to continue that and draw the over 1, down 2.5, you're more than welcome to do that. If I'm asking you guys to do this by hand and graph this, there's other methods for solving quadratics. If I'm asking you to graph it by hand, it should go through a nice value. Otherwise, like I said, there's different methods for solving these that we would use instead. So we're going to do -6, -2. If you're being asked to graph this by hand on a grid, should be nice answers to the question. Is anybody having a question? Okay. Now, I'm going to have you, if you guys want to go through and do this, you can. We actually did this in our last unit. I was just going to have you do a system, but let's just skip it so we have some extra time, and I'll cut that homework problem off. So don't worry, we did that in our last unit, but we would just graph the parabola, graph the line, see the points that they have in common. We already did that algebraically, actually, we did that in our last lesson, but we did that in Unit 3, so we don't have to worry about that right now. The rest of what we're going to do on the back, I'm going to write down how to do this on the calculator. So this says solve using your graphing calculator, and then it says round answers to the nearest hundredth. It's kind of trying to imply to you that we're not going to have nice answers to this question. So the first thing, any quadratic that you're going to solve, you want to make sure you set it equal to 0. So I'd have to do just like one quick step on this question to do that, and that'd be to subtract the 6x. So I'd have 3x squared minus 6x minus 5 equals 0. Now, we're going to do what we did on the front. We're going to graph on our calculator the related quadratic, which would just be 3x squared minus 6x minus 5, and then we'll see where it crosses the x-axis. I'm going to show you the process for how to do that on your lovely calculator. So before we start, and just because we've been using this a little bit, I'm going to type the equation. My first step, we're just going to go to the y equals button, which is in your upper left corner, and you might have something in here, so I'm just going to get rid of it really quick. And the other thing you might have, so we were doing a bunch of stuff with some data, so you might have a plot turned on. Some calculators do not like it if you have the plot turned on and then try to work with a different equation. So if you have a black background on any of those plots up there, just arrow up to the top. I'm going to hit enter and arrow away from it. That'll make it so it doesn't have a black background. So all I did, I hit enter. When I have that kind of flashing, hit enter and arrow away from it, and that just turns it off. Okay, now we're going to type in our lovely equation, which was 3x squared minus 5x minus 6. Make sure when you're doing this in here, you're subtracting between the terms, so use the subtraction sign. Don't use the negative key here. Once you type in, so I'm going to write type equation here for my directions. I'm going to have everybody just do me a little favor just so we start in the same place. I'm going to have you hit the zoom button and then pick number 6. That just gives you a basic -10 to 10 window. It says zoom standard, so I just hit zoom and the number 6 just so we all start in the same place and we can manipulate it as we need to. But in this case, we can see where the graph crosses the x-axis in both places. So I'm actually going to just leave that in terms of changing anything around with the zoom alone. All right. Now, we're going to have to do this twice because you have 2 zeros. You're going to hit second and then trace, which we've seen this menu in several things. So second trace, and you can see right there in one of the options, number 2, it says is a 0. So I'm going to hit that. Okay, now actually I'm going to scooch this over just a little bit. Let me sketch you a tiny picture, just kind of what you're seeing, so I can And this can be tricky. So here's like my x. I'm just doing a little sketch of this. You guys can kind of see it crosses between like the -1 and the 0, and then it crosses over here between like 2 and 3, but it's not on a nice value. Hopefully you can see that. Okay, now I did second trace and I picked 0. And if you look across the bottom of the screen, it says left bound. All right, I'm going to draw this on the picture so you guys can see. You have to come somewhere. I'm going to see where the 0 is. I'm going to come somewhere on the left side of that. So I'm just going to move the cursor. Really, it just needs to be above the x-axis. Just anywhere above the x-axis. And then you're going to hit enter. Okay, now for this, as I'm approaching this, you're coming from the left. I'm using the right arrow key. It says right. The right of that 0 would be somewhere just below the x-axis. All right, here's the 0. As I'm approaching this, to come from the left, you'd be above the x-axis somewhere, and then on the right side of that would be below the x-axis. So again, just somewhere below, just hit enter, and then it will say guess. Just hit enter a third time, and it should go right to that point. And these guys just say to the nearest hundredth. So I'm going to write down... Oh my goodness. Hold on a second. You guys did the equation right, and I totally did not. Fail at life. Okay, my fault. It was -6x. No one stopped me. I just got on a roll. Okay, hold on. I went back to my y equals. I'm really sorry. I said that wrong too because I had my calculator over it. It was -6x minus 5. So if you didn't do that, go ahead and change that real quick. Okay, we'll practice this one more time. All right, so my 0. I'm going to come somewhere on the left side, which would just be above the x-axis, somewhere on the right side, below the x-axis, and then it should go right to that point. Sorry, I knew that number was wrong. So it's about 0.63 negative if I round that to the nearest hundredth, 2 decimal places. 100 has 2 zeros, so nearest hundredth. Now, if you have another 0, which we do, you have to start from scratch and just repeat what we just did. So I'm going to hit second trace, go to the 0, or hit number 2, should bring you to the graph. Okay, the other 0. Now I know this is weird. Now as I'm approaching this, I'm just using my right arrow key here. As I approach this from the left, now the left side as I approach this is going to be below the x-axis. Here's the 0. And somewhere on the right, as I approach this, is going to be above the x-axis. So just left side underneath, move it up a little bit, right side above the x-axis. Again, it will say guess. Just hit enter, and it should go right to it. And if it's asking you to use the calculator to do this, it's probably not a nice answer. So this is going to be about 2.63 to the nearest hundredth. And I was just sketching that little picture for you because it depends on which one you're going after, where the left might be and where the right might be. The one of them has to be above the x-axis, one of them has to be below. It's just as you use the left and right arrow keys how you're approaching that. Is anybody having a question or not getting that? I'll come look at it in 1 second. While I'm going to go look at his real quick. Type this equation, like go back into your y equals, and we're going to type this equation, and it's going to model how this frog is traveling. Okay, anybody else? Now, we're going to do this little guy here. So I have a little picture of a frog, and I'm going to have you guys manipulate something a little bit for me. So I'm going to go to y equals here real quick, and I'm going to get rid of the equation that we had for that previous example. I'm going to do, you don't have to put the 0.0. You can just start with the decimal point, which I'm just going to do that. But I do need a negative, so make sure you use the little negative key in front of this. It's 0.029. You don't need the 0 in front. You can put it, it doesn't matter. But it's 0.029 x squared. and then plus, again, you don't need the 0. I'm just going to put 0.59x. You can put the 0, but you don't have to, in front of the decimal place. So this says this, here's a kind of a sketch of the graph, and then it says the function is modeling the height of the frog's jump in feet from the distance, and the distance from the jump's start. So here, this would be how high the frog gets in the air, and then the x-axis is going to be the distance the frog travels as he jumps here. So I have 2 questions, and then they're going to be related to what it asks you at the bottom, which is for the domain and the range. So what am I looking for, or maybe where on the graph, what point or points am I looking for if I ask you to find how high the frog jumps? Yes, ma'am. Yes, 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 yes. Vertex here. Okay, now, specifically, it would be the y-coordinate of the vertex. The x-coordinate is just going to be the horizontal distance that the frog travels, but how high in the air, that's going to be the vertical distance, so that's going to be the y-coordinate of the vertex. Now, if you want to, you could do negative b over 2a and find it from the equation. I'm just going to show you real quick how to use the calculator to do that. And I think we did this before, but I honestly can't remember. So if we got the equation in here, if I want to find the vertex, you're actually going to go to that menu that we were just using. We're going to hit second trace. Let me go ahead and hit the graph. Actually, before I do that, do I have, if I just like pull that up on the screen, do we have a good picture of that graph? It's not the greatest. I'm going to try to find the vertex so I can kind of see that. I'm not sure that I see that on the screen there. There is something you can do if you don't want to use the zoom buttons, and I do this a lot. There is a button across the top next to the y equals that says window. And I can kind of tell here, like my x values don't go over far enough. Does that make sense? Like I need to go farther to the right. So a lot of times what I'll do is instead of using the zoom keys, I'll just go into the window. And yours might look a little different than mine depending on your calculator, but everybody should have an x min and an x max. So the minimum x value just says on the left side it's negative 10, on the right side it's positive 10. So maybe I'm going to make my x max like, I don't know, let's make it, it's at 10, maybe I would just go, I don't know, I'm going to make it 30. You can make it whatever you want, but I'm just going to try and move the graph so I can see the parabola a little bit better. The y's were fine. I mean, you can manipulate that as well. Don't mess around with the scale. That just tells you it goes by ones. The y min, that means the lowest y value is negative 10, the highest y value is positive 10. I'm just going to leave those alone for this, and then don't mess with the scale and the, if you have it on their resolution. But min and max you can always mess around with. So I just changed my x max to be 30, so then I can kind of get a better picture of the parabola there. And you could, and if I went in, like, here, I'll show you this. Like maybe if I did, okay, let's just move it over to 15. And then I can kind of say, okay, I didn't go over far enough. So maybe I just make that a little bit bigger to make sure I can see it on the screen. So you can pick whatever number you want, and it's easy to go back in and change that. So I just picked 30 just to see if I could get a good picture. Okay, you have to be able to see the vertex to find the vertex. So now I can see the vertex. So second trace, and in this case, because the graph is turned upside down like it is, the vertex is a maximum. So I'm going to pick number 4 here. If the parabola turned the other direction, you needed to find the vertex, we'd have to pick minimum. So it depends on how it turns. Now, this is kind of similar to the 0. You're going to come like left side, right side. So if you're looking, here's my parabola. Kind of eyeball where you think the vertex is, somewhere on the left of that vertex, and then you want to come somewhere on the right. It doesn't have to be at an exact spot, but just so the vertex is in between the two values you pick. So I'm just going to kind of hold down my left arrow key and just go to the left of where I think that vertex is. Now, yours might pop up a little line like mine does, or it at least pops up a little arrow. It's saying, okay, calculator, start here. So there's my left, and then I'm just going to hold my right arrow key down just somewhere on the right of where you think the vertex is. Hit enter, And then it should pop up another little arrow, maybe a line like mine does, and it's saying, okay, calculator, I need you to look between these two values for the maximum point on the graph. So that's why you got to do the left side, right side. It will say guess again. I don't know why. Just hit enter, and then it should go right to the point of the vertex. And I'm just going to round these to the nearest hundredth because that's what it said in the original directions we had. So I have the point 10.17-ish is my x, and the y is actually 3. Now, the answer to my question here, how high did the frog jump? This should just be 3 feet, the y coordinate of the vertex. Now, two things, but I'm going to show you this. Because the frog in this picture starts at 0, 0, I could actually use symmetry here to just, like right here in the middle, you'd be at the 10.173. I can just use symmetry to actually figure out the 0 here, since this started at 0, 0. So I could just, like right in the middle is 10.17, I could just double that, right? You could use symmetry to just double that. So I know how far the frog jumped. This is going to be this point right here, the x coordinate of that point. The y coordinate's going to be 0 because the frog's going to be back on the ground. But I could, using symmetry, because it started at 0, 0, I could just double this because the 10.17 is directly in the middle. So it would be 20.34. And then 0 would be the y coordinate because the frog's back on the ground. So I can use symmetry. Now, if you don't start at 0, 0, you could use what we did above, which, let me just go through it with you one more time so to show it to you again. You can also do that second trace and find the 0. Just left side of where you think it here. The left side would be above the x-axis, and the right side, I'm just holding down my right arrow key to get underneath, move it a little bit faster. On the right side would be underneath the x-axis, and then just hit enter and it should go right to that. And you can actually see it's 20.344, so it's the same thing, but you could use the symmetry there if you start at 0, 0. If you don't start at 0, 0, then you can't use the symmetry unless you know the other 0. So you can use symmetry here, but in case you can't, you can also use that method we just used above. So then here, reasonable domain. So my x values, right? The frog starts, he hasn't jumped yet. So no distance has he traveled when he starts his jump. I'm going to put a bracket on that. Then he jumps, gets back down on the ground here, and this was 20.34, what was this in feet away. But again, I'm going to use a bracket there because I stop and I'm back on the ground. Don't continue, we wouldn't go negative there for the graph, for the frog's distance. And then your range, again, you start on the ground, and we saw that the maximum height at the top of the jump was 3 feet. So that's how high he gets up here, 3, and then the gravity's going to bring him back down to the ground. Those would have brackets because we're going to remain connected to this word problem. Is anybody having a question? Okay, I'm going to shut up. If anybody